Okay, we're going to do hyperbolas. We'll just call it hyperbolas, period, and then maybe tomorrow might be part 2. I don't know. Okay, so we're going to do the same thing that we've been doing for every single one of these conic sections. We're going to define it, we're going to draw a picture, we're going to label all the pieces. Okay? So a hyperbola is the set of all points in a plane, the difference whose distances from two fixed points called foci is a positive constant, which is 2a. Okay, so we're going to just draw this. And again, you know, same thing with an ellipse or a parabola. It could be horizontal or it could be vertical. So we're just going to pick one and draw it. We're going to go with a vertical one. I think, though, what we're going to do is we'll define a piece and then we'll add it to the drawing because it will give us a more accurate picture. Okay? So a hyperbola is like two branches or like two curves or two parabolas, you can think about it like. Okay? And again, they can be, you know, horizontal or vertical. Okay. So the first thing we're going to have is the center, and we're going to label it with a C, and it is also going to be HK, just like it has been for every single one we've talked about so far. So let's pick a point and just label it with a C. Okay, so then you're going to have vertices. And the vertices are like the max and the min of each branch, or each curve, or, you know, each piece of that, you know, the half of the parabola, like. Okay, so now above this, let's just put a vertex here and a vertex here. So there are two of them. Okay. Then there are endpoints, okay, but they really don't exist necessarily on the graph. It's just they help us to graph the whole hyperbola. So let's just make ourselves a note here. They're like a tool to help graph. Okay. And then there are going to be foci, just like there were before. Okay. And the foci are inside of each branch. Okay, so here let's just mark this with an asterisk and an F. Same thing down here. Now all we have is a bunch of points in a row so far. Okay. So there are these endpoints that exist, and they will be to the left and to the right. Okay, and the reason why we put them on our graph is really just so that we can create this like fake box, basically. Okay, so you're going to have like this box, this rectangle, that connects your vertices and endpoints, and you're going to draw it in dashed on your graph. Now the reason why we have this is because with a hyperbola there are asymptotes. Okay, so let's define those. Alright, so the asymptotes are lines going through the center, and what they do is they help us to shape the curve. Okay, so now there are these asymptotes that go through the vertices of this rectangle, and they also go through the center. Okay, and anytime you draw in an asymptote, we always draw it in as like a dashed line. Now remember, this is a line that the graph cannot cross. Right? We learned about asymptotes in chapter 2. So once we figure out all of these pieces, then we can finally draw in the hyperbola. See, none of this is the hyperbola yet. The hyperbola are these two branches that exist. So they're going to approach the asymptotes. They're going to go through the vertex, and then that's going to happen twice. So it looks like this and that. And that is an example of a vertical hyperbola. Okay? Yeah. Yeah, you learned this last year. You mean this year, though?
Yeah.
It's like all the same pieces, so that's kind of the nice part, but there are some differences we're going to talk about. So you'll remember, like, in an ellipse, it had all these same things. So that's why it feels, like, similar, okay? But some of the pieces are a little different. We're going to talk about that now. So A, we still have A, B, C, and D. D. No, there's no D. A, B, and C. How about just that? A. I was going down the line. Okay, A is the distance from the center to a vertex. Okay? B is still the distance from the center to an endpoint. C is still the distance from the center to a focus. Okay, so all of those pieces exist the same way they did in an ellipse. So let's go ahead and just highlight that. So A is the distance from the center to a vertex. So this is A. B is the distance from the center to an endpoint, just like it was in an ellipse. And C is the distance from the center to a focus, just like it was in an ellipse as well. Yes?
Is the B really greater than A?
Yes. Not always. C is greater than A always. We're going to talk about that next. Okay, so there are different rules, and this is where the hyperbola gets a little confusing, because all this stuff that we just talked about in an ellipse, it all slightly changes. So you got to keep it all straight. All right, so here are the rules. Remember how in an ellipse c squared equals a squared minus b squared? No, it doesn't. C squared equals a squared plus b squared in a hyperbola. It is. It's like a right triangle, perhaps, like the Pythagorean theorem. I know, look at all that. Okay, so that needs to be definitely memorized. Okay, that's important. The other thing is that A is less than C always. Which, now think about why. A is the distance from the center to a vertex, and the focus is inside of the branch. Well, isn't the focus going to be farther away from the center if it's in the inside? Yeah. So that makes sense. Visually, you can remember that. All right? So this is another rule you have to remember. These asymptotes, they have some simple rules. Now, the book's going to give you this complicated formula to use. Don't use it. Okay? Let's just think about an asymptote. Isn't an asymptote just an equation of a line? Yeah. Right? They're lines. So if you can think about the equation of a line, what are the two things you need in order to find the equation of a line? Slope and y-intercept, right? So that's how we're going to think about it. So if you think about this parabola right here, isn't the slope of this line a over b? Right? It's rise over run. So when it's vertical, you will have slopes of plus and minus a over b. But if I was to turn this hyperbola, then the asymptotes would have slopes that were b over a. So when it's horizontal, the slope is b over a. And as we kind of look at this, it'll make more sense seeing the slope of that line. Okay, so you can memorize this as well. It may be helpful to you. If not, you can just kind of look at the picture and figure it out. Okay? What else do I want to tell you? Eccentricity, remember that? Right? It's still like the same. It's still C over A, so that didn't change. But remember the LR, the latus rectum? Yeah. That exists here too. but it's a different formula, and this you do want to memorize. So the LR is equal to 2b squared over a now. Okay, so these are all pieces that I expect you to remember about the hyperbola. Now you need some equations, right? We've got to add that to the list as well. So this is the standard form of an equation. Of a hyperbola. And just like the ellipse, there are two of them. Just like the parabola, there are two of them. So, what do they look like? Well, they look like this. X minus h squared over a squared minus y minus k squared over b squared equals 1. Or y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay. So here's the deal. What do you notice about these equations? Like different than the ellipse, say. Colin? Yeah, this is huge. This subtraction right there. When you have a negative squared term, you know it's a hyperbola. Okay? So there's this minus. The other thing is that notice now that y can come first. Right? All the other ones always have x first. Y can come first, and this is how you know whether it's vertical or horizontal. When the a squared term is under the x, it's going to be horizontal. So it's going to look like this. Okay, it's horizontal. Bless you. And when the y squared term is positive, then it's going to be vertical. Looking like this. So here's the rule you want to remember. A squared is always under the positive term. Okay? Let's add this to the list of things to remember. A squared is always under the positive term. So whichever term is positive, you look under there and that's a squared. So that's how you always know what a is based on the equation. Okay? So a squared here is with that positive term, and a squared is with this positive term. Right. Okay? So wherever the positive term is, that's your a. It'll always be first. Yeah.
Okay, so A is always in the front.
Because we always want our positive term in the front. Right. Okay? Alright, I think as we go through this, it'll make more sense too. Because right now it feels a little different, but it's also going to feel familiar once we start talking about the pieces. Okay? So here we go. Let's turn the page now and let's start a new example. Alright, we'll call this example 1. Find the center, vertices, foci, and asymptotes. Sketch and label a graph. Okay, now notice here it doesn't ask you to find the endpoints. And that's because the endpoints don't really exist in a hyperbola, right? It just kind of helps us. But we're going to find them anyways because it's going to be fun. So let's just make ourselves a little note here. Let's find the endpoints too. Because I'm just trying to be happy today. It's a struggle.
What cup are you on?
It's a small detail I'd rather not reveal. Not today. Sale's over. Okay. So, y squared over 25 minus x squared over 36 equals 1. This is given. Okay, first of all, the good news is this is in standard form, right? Like, there's no completing the square right now. So that's a plus, okay? Talk to me about all the things you see. Okay, so center 0, 0. Now, here's what I'm going to warn you about this. Remember with the parabola how, like, y could be listed first, and I said be careful when you talk about the vertex because you don't want to switch it. Yeah. Same thing can happen here, okay? You got to make sure you're looking at x first, then y next, all right? So just keep that in mind. What's the direction? What orientation is this? Horizontal or vertical? Vertical. How do you know it's vertical? Excellent. So this right here tells us this is vertical. What else do you know? What's A? 5. What's B? 6. So this has to be a squared, right? Yeah. This has to be b squared. How do you find c? Put that in formula. C squared equals a squared plus b squared now. So c squared equals 25 plus 36, so 61? 61. And that means this has got to be the square root of 61, right, if it's just c? The other one was a squared minus b squared. Yep, got to keep it all straight. All right, now we're going to find the vertices. We're going to find these fake endpoints. We're going to find the foci. We're also going to find the asymptotes. So this is our list of stuff we're looking for. Okay. Before we do this, we should draw a picture. Okay. So the center is at 0, 0, and we know it's vertical. So the vertices are a distance of A away from the center, right? Yeah. So we got to count up and down 5. So isn't that going to put one vertex here, like at 0, 5, and the other one at 0, negative 5? Okay. So remember, this is just a rough sketch, so... you know, it's not that rough, though, I guess. Let's just draw this in because we want to see these asymptotes. Okay, so we're going to be a little bit neater on these sketches. Now, how do you find the endpoints? Yes. So the distance is 6, so I'm going to count over 6 and have my endpoint, and I'm going to count over to the left 6. And have an endpoint. So these are at like 6, 0 and negative 6, 0. Okay, so now I can form this like little fake box. Okay? I guess it's not that fake. It's just, I don't know. Alright. Okay, so just drawing this little dash box because this is going to help us to draw the most accurate picture we can. Okay? Where are the foci? How do I find those? So I'm going to count from the center, up and down a distance of c, right? So I'm just going to add the square root of 61 to 0. So I have 0, root 61, and 0, negative root 61. Now we could put that in the calculator and figure out where it was, or we could just guesstimate. Okay, so now it's time to find the asymptote. So notice this is like all the same stuff that it was before. The picture's just looking a little different. Alright, so now the asymptotes are going to come in by us thinking about what does the slope look like. So everyone agree that these are our asymptotes. Okay, so we're going to draw those in. And now at this point we are ready to draw the hyperbola itself. So remember, you want to approach the asymptotes, go through a vertex. These should be curves, not sharp points. Okay, so there's our sketch. Now, what does the slope look like of this positive line? Isn't it a distance of A over B? Because this is the rise, which is a distance of A, and this is the run, which is a distance of B. So I'm going to start out with y equals plus or minus A over B times x plus B. This is the format that this asymptote is going to take. Now, if you look over here at this negative line, that's why it's just the negative version, right? It's still the same distance of A, it's still the same distance of B, except this time we are a negative slope, right? Falling, left, right. Okay, well, this is what you do. You plug in A and B. So what's A? 5. What's B? 6. And then we have X plus B. Then we're going to have a second one. Y equals negative 5 over 6X plus B. So this is how you start out. I want you to think about how would you find B? What point? The center, because the center is a point that lies on both of these lines, isn't it? Now in our case, we can see the y-intercept, right? It's just 0. So if I plug in 0 and 0, B is 0 in both of these cases, right? So when it goes to the center, it's much easier to find the asymptotes than when it doesn't, okay? So our asymptotes are located at y equals 5 over 6x and y equals negative 5 over 6x. When you do your homework, the book is going to list this way differently, okay? I want them listed like this. Sound good? And then that's it for this one. Okay? Good? Okay, time for B. Still the same directions. Here's the equation. 9x squared minus y squared minus 36x minus 6y plus 18 equals 0.
You gotta do that one thing, you gotta make them all.
That one thing.
The 2 completing of the square.
We'll be completing the square on this. Yep. I know. So, what should we do first? Group them together, right? First of all, can you look at this equation and see that it's a hyperbola right now? Yes, you can.
Yes.
Oh, they're all negative.
Yes, you can. Not because they're all negatives, but because of this one specific negative. So that right there tells you there are 2 squared terms. One of them is negative. That is telling you this is a hyperbola right there. Okay? It's also telling you something else. Isn't it telling you which direction it's going? Because if the x squared term is positive, then doesn't that make this horizontal?
Yeah.
Right? So right now you know this is a horizontal hyperbola and you've really done nothing else. Okay? All I've done is look at the equation. So let's make a note of that. Okay. Now we're going to group them together. So I have 9x squared minus 36x minus y squared minus 6y. And I'm just going to move over the 18 now. So equals negative 18. Okay. So remember, you have to have a coefficient of 1 to get started. So I should take out a positive 9. So I take out the 9 out of both of those x terms, and I'm left with x squared minus 4x. I'm going to leave a space. What do I have to take out of the next two? A negative 1, okay? So I want minus 1 times y squared plus 6y, leave a space, equals negative 18. If you are not comfortable with this, you really need to see me, okay? We need to go over this until you are, because this is imperative for this unit. Okay, so now I take half of b, so I'm going to have a negative 2 squared. Inside I'm adding a 4. Times the 9 means I'm adding 36. So I'm going to have to add a 36 over here. Here, I'm going to take half of 6. So I have a plus 3 squared on the inside, which is like a plus 9, times a negative 1. So I'm subtracting a 9 here on the left. I need to subtract a 9 here on the right. Now I'm ready to factor. So this factors to 9 times x minus 2 squared minus 1 times y plus 3 squared equals, is that 9?
Yes.
Okay. Not done quite yet. There's one more step. I have to divide by 9 because this has to equal 1. So I'm dividing by 9 everywhere. Okay? So I have answered nothing of what they've wanted yet. Right? all I've done is put this into standard form. So before you can find any of that information, you need to do that first. So now this question wanted me to find the center, the vertices, the endpoints, the foci, the asymptotes. And make a sketch. Okay, so we have already discussed the fact that this is horizontal, right? Because we can see that the x squared term was positive. So it's still positive. We're good to go. What is A? 1. It's the number under here. There is no number, so it has to be 1. What is B?
3.
So what is C?
3.
So C squared is the 10, so therefore C is the square root of 10. Everybody agree with that? You have to add A squared plus B squared. Okay, so let's start the sketch and see where we get. So this time, where is our center? 2, negative 3. So 2, negative 3 is here. Okay, I have vertices a distance of 1 away. Do I count left or right, up or down?
Left and right.
Left and right, because this is vertical. Okay, so that's going to put these at 1, negative 3, and 3, negative 3. Now I'm going to put the endpoints in because it's going to help me to make my most accurate picture, and it's going to help me to find the asymptotes. So the endpoints are a distance of 3 away, and don't I have to count up and down? So here is one of them, here is the other. So those are going to be located at 2, 0, and 2, negative 6. The foci are a distance of C away, and I'm going to have to count left and right. Agree? Okay, so then they're going to be at, let's see, 2 plus the square root of 10, comma, negative 3, and 2 minus the square root of 10, comma, negative 3. So here and here. Okay? I can draw this box in now. I can draw my rectangle so that way I can form those asymptotes. Okay, so I'm drawing this in. And this one. I can now form those curves, creating those branches of the hyperbola. Move it up. Okay, now these asymptotes aren't going to be as easy to find because the center is no longer at 0, 0. But I'm still going to think about it the same way. Okay, so I'm going to think about the slope first. So is the slope A over B or B over A? B over A, because I'm going up to an endpoint and over to a vertex. Okay, so I'm going to have B over A. So this time when I set this up, it's going to look like Y equals plus or minus B over A, X plus B. These B's are not the same. Not ideal, but, you know, it's fine. Okay, so I'm going to start with Y equals B was 3 and A was 1 times X plus B. And I'm also going to have Y equals negative 3 over 1X plus B. Do you understand where those come from? Okay, so now I want to think about how do I find B? You plug in the center because, see, this center is still a solution point of both of those lines. So we're going to plug in X and Y, okay? So this is going to be negative 3 equals 3 times 2 plus B. And this one's going to be negative 3 equals negative 3 times 2 plus B. And we're going to solve for B. So here B is, what, a negative 9? And B is 3 here. So that's going to put our asymptotes at Y equals 3x minus 9 and Y equals negative 3x plus 3. So this is everything this question asked for. Now we're going to do example 2. So this time we're going to write the equation of the hyperbola. Okay, so this is the information we're given. The center is at 0, 0. A vertex is at 0, 2. And a focus is at 0, 5. Now, hopefully you've been catching on to the pattern here. Anytime you're going to write an equation, you have to draw a picture to visualize it. Okay? So we're going to start with a sketch. This is going to be a super, super rough sketch. It's just giving us an idea of the pieces that we've been given. So I have the center at 0, 0. I have a vertex at 0, 2. And I have a focus at 0, 5. Now think about what that means. First of all, doesn't that mean that I have all that information mirrored below?
Yeah.
Right? And it also, doesn't it mean that the hyperbola looks like this? Okay? That is enough of a sketch. Because now think about all of the pieces that we've been given. If this is vertical, what comes first? X squared or y squared?
Y squared.
Y squared. And we know the center is 0, 0. So it's going to be like y minus 0 squared minus x minus 0 squared equals 1. And then both of these pieces have to be under A and B, right? And doesn't A have to come first?
Yeah.
Okay, so we know this has to be A squared, and this has to be B squared. What is A? 2, because it's the distance from the center to a vertex. So I know that this is 2 squared. Don't you also know C? So C equals 5 because it's from the center to a focus. So now I can find B squared because I know that C squared equals A squared plus B squared. I know C, so this is 25. I know A, this is 4. And then B squared must be 21, which is the piece I'm missing, right? So this has to be 21. And now let's just write it neatly. So we're not going to write these minus zeros, right? We're going to have y squared over 4 minus x squared over 21 equals 1. And that's our equation. Okay? Yes?
So the hyperbola, we can draw it because all it has to do is go through the vertex.
Right.
Okay.
Right. I'm not really concerned with what this looks like. I really just want to pull the information from it. Okay.
Like the point of the foci, like why do you need it at all?
Because we had to have C. We have to know C. And remember, this forms it because every point here is equal distance away from it. Okay? Now, let's look at B. The vertices are plus and minus 3, 0. And the asymptotes are y equals plus or minus 1 over 6x. Okay. So, let's draw our picture first. If the vertices are at 3, 0 and negative 3, 0, what's the orientation here? Horizontal. It's got to look like this, right? Doesn't the center have to be in the in-between? Right? Directly in the middle. So the center has to be at 0, 0. So that means that this is a positive x squared, right? So far I know x squared minus y squared equals 1. Do I know A or B?
Yes. We know A.
We know A. Isn't A 3? Right? Because it's a distance from the center to a vertex. So that means that this is 9. Okay, now we got to think about this for a second. Remember that imaginary rectangle we had going on here?
Yeah.
Right? And then we had these asymptotes, right? We don't really know if this is exactly how it looks, but let's just visualize it for a second. These asymptotes have to be B over A, don't they? So the rise over the run is B over A. They're giving you the slope here. The thing about this slope, though, is we don't know if it's been simplified, right? So we got to run with what we know. We know this represents B over A, and that's going to be 1 over 6. But go back.
You know?
Don't we know that A is for sure 3?
Yeah.
So we want to substitute that in. So I have 3 over B. So this is the proportion I want to solve in order to find B. So we cross multiply, we get 6B equals 3, so therefore B equals a half. Now I can plug in B squared, which is the only piece I was missing. It's going to look really weird, right? Because it's a fraction. So it's going to become a compound fraction, but that's allowed in conic sections. So when I plug in B, what is B squared? A fourth. So I'm going to write a fourth here. And even though it looks really strange, you're allowed to write it like this. Okay? And that's our equation.